All right, strap in, everyone. Let's dive deep into the world of tool grinders.
We're going to get you prepped for that interview.
You'll be speaking the language of precision, metal, you name it.
Yeah, we'll break down those tough questions.
Give you the answers to help you stand out, like really stand out.
Even if you've never been a tool grinder before, we'll show you how to shine.
We've got the career guide for tool grinders.
Insider knowledge right here.
And, of course, we'll sprinkle in some of that RoleCatcher AI magic.
To tailor your responses.
But first, what does a tool grinder actually do? Day in, day out. It's more than just, like, sharpening, right?
Way more.
We're talking precision, manufacturing, engineering, metalworking.
The backbone of it all.
Okay, picture this. You're in a machine shop.
Hear that hum of industry.
Yeah, and you're surrounded by powerful grinders, shaping metal with incredible accuracy.
So you're not just grinding, you're crafting.
Each tool, each part.
Got to fit perfectly.
It's demanding work, detail-oriented.
And in high demand across so many industries.
All right, let's jump into some questions you might get in that interview.
Let's do it.
First one, what experience do you have operating those tool grinding machines?
Okay, so maybe you haven't spent years on a specific machine.
That's okay.
But think about it, have you worked with other machinery?
Anything that involves precision.
Woodworking, even model building, those skills transfer.
It's all about understanding those underlying principles, right?
Exactly. Angles, tolerances.
That dance between the tool and the material.
You've been training for this your whole life, maybe without even realizing it.
I love that. So even if you haven't used a specific tool grinder,
You've got the foundation.
and this is where RoleCatcher comes in,
Ah, yes.
that AI analyzes the job description, and then,
It suggests how to highlight the most relevant skills.
so if they're looking for experience with CNC grinding,
You can emphasize your computer-aided design skills or programming.
all right, next question. Can you explain the difference between a single point and multi-point cutting tool? Sounds technical.
A bit, but don't worry.
With a little prep.
You got this.
So totally.
Think of it like this. A chisel, that's your single-point tool.
One precise cut at a time.
Now imagine a saw.
Multiple teeth.
Multi-point, working together.
Okay, so single point, like a focused expert. Multi-point, a team effort, each with their own role.
Showing the interviewer you get it, you're interested in the craft.
Not just looking for a job.
And speaking of getting it, what if they ask about diamond versus CBN wheels?
Oh, now we're getting into the specifics.
Time to break out the career guide for tool grinders.
Gold mine of information.
For real, diamond wheels, those are your champs for super hard materials.
Ceramics, things like that.
The heavy hitters. CBN, on the other hand,
They shine with hardened steel.
the specialists.
So it's not just about the names.
Nope.
Gotta understand the why,
Why choose one over the other? That's what shows you're thinking critically.
not just memorizing.
And guess what? RoleCatcher can quiz you on all this.
Re-
Even give you feedback on your explanations.
It's like having a personal tutor. Awesome. Okay, next question. How would you ensure the quality of the tools you're grinding? Time to show off your meticulous side.
Your attention to detail. You're crafting precision instruments, remember.
Right.
Talk about using those precise measuring tools.
Micrometers, gauges,
Constantly checking, double checking.
every dimension's got to be spot on.
Absolutely.
And don't forget to mention any experience with quality control systems.
Even if it's from a different field, it shows you understand the importance of standards.
Okay, let's move on to problem solving. Because every job has its challenges, right?
Of course.
They might ask. Have you ever had to troubleshoot a tool grinding machine? Give us an example.
So the career guide says analytical thinking is key for tool grinders.
You got to show, not just tell.
Right. Think of a time you faced a challenge, maybe even outside of tool grinding.
A machine, a process, anything.
Explain the situation. What was the problem?
And how did you analyze it? What steps did you take?
And what were the results?
Like telling a detective story.
With you as the hero.
Exactly. And using the STAR method can really help you structure your answer.
Situation, task, action, result.
Clear, compelling. All right, let's say they ask, how do you keep up to date with the latest developments in tool grinding technology?
Show you're committed to continuous learning. That's huge, according to the career guide.
It's like saying, I'm not just content with what I know now. I want to keep learning, level up my skills,
Right. You could mention professional organizations.
like the International Association of Machinists and Aerospace Workers,
Or the National Tooling and Machining Association.
trade publications, webinars.
Industry blogs.
Show them you're passionate.
And always looking to stay ahead of the curve.
Okay, let's talk safety, another likely question. How do you ensure the tools you're grinding are safe to use?
This one's all about those safety protocols.
Which are paramount in this field.
Sure.
So, talk about PPE, personal protective equipment.
Those safety glasses, gloves, ear protection.
They're not just accessories, they're essential.
Absolute.
Mention your commitment to those safety guidelines. Routine maintenance, being mindful of hazards.
You want to be a safety champion.
Show them you take this seriously.
All right, next up, organization. They might ask, how do you prioritize your workload when you have multiple tool grinding jobs going on?
The career guide emphasizes time management.
It's a must-have skill.
Show them you can handle it. Juggle those tasks without sacrificing quality or those deadlines.
Think about how you stay organized. Do you use to-do lists?
A project management app, maybe?
How do you prioritize based on urgency, importance?
And give specific examples. Like, imagine you have multiple rush orders.
How do you handle that? What are your strategies?
Real-world examples bring those answers to life.
And don't be afraid to mention tools or techniques, even if it's just a to-do list app on your phone.
It shows you're proactive, organized. Okay, let's tackle another question. Have you ever implemented process improvements in your tool grinding work? Give us an example. This is your chance to show initiative.
Going above and beyond.
And the career guide highlights that commitment to quality and efficiency.
So think of a time when you made things better, more efficient, safer.
Don't just say you improved things.
Yep.
Explain how it led to a specific outcome.
Did you reduce waste, increase output, enhance accuracy, make it safer? Those are the specifics they want to hear.
Quantifiable results.
Okay, last question for this round. Can you explain the difference between plunge grinding and traverse grinding? Back to the technical side.
And this is where RoleCatcher can really come in handy.
You can practice those technical explanations, get feedback.
Make sure you're clear and concise.
So plunge grinding, imagine using a cookie cutter.
You're creating a specific shape.
The grinding wheel goes straight into the material.
Traverse grinding, on the other hand.
More like sanding back and forth.
Okay, so plunge grinding, precise cuts. Traverse grinding, smooth, continuous surfaces.
Having a clear understanding of these techniques shows you're not just surface level, you know the details.
We've covered a lot of ground here, but don't go anywhere. We've got more interview questions coming up after the break.
Stay tuned. All right, let's keep those interview questions coming. You ready?
Ready to roll.
Okay, imagine the interviewer asks, what are some of the challenges you've faced as a tool grinder, and how did you overcome them?
Ah, the classic, tell me about a time you faced adversity question.
Right. Everyone loves this one.
But it's a great opportunity to show them you can handle pressure.
Problem solving, resilience, that positive can-do attitude.
We want to see you can learn from your mistakes, come back stronger.
Exactly. So think about a specific challenge you face.
A technical glitch, maybe?
A tight deadline.
Or a project that really pushed your skills to the limit.
Tell the story. Don't just list the problems.
Paint a picture. What were the obstacles? How did you navigate them?
And how did you solve the problem? What did you learn from the experience?
Maybe you found a creative workaround or collaborated with your team.
Or maybe you discovered a hidden strength.
The career guide talks about adaptability and problem solving. This is your chance to really show those skills.
Okay, here's another one you're likely to hear. Describe a time when you had to work effectively as part of a team.
Teamwork, essential in any workplace. The tool grinder world's no exception.
Right. Think about a project where teamwork was key.
Doesn't even have to be related to tool grinding.
What was your role? What were the challenges?
How did you overcome them together? Did you delegate tasks?
Resolve conflicts? Brainstorm solutions?
The career guide highlights communication and collaboration, and RoleCatcher's AI can help you tailor those answers.
Make sure they align with the job description.
Exactly. Okay, back to the technical side. They might ask, can you describe the different types of grinding wheels and their applications?
Time to show off your knowledge. Remember those diamond and CBN wheels?
Just the beginning.
There's a whole world of grinding wheels out there. Aluminum oxide, silicon carbide.
Even ceramic materials.
Each one designed for a specific material or task.
Like having a toolbox full of specialized instruments. You wouldn't use a hammer to tighten a screw.
Exactly. And the career guide emphasizes that. Using the right tool for the job.
So be ready to talk about the properties of each type of wheel, the hardness, the grit size.
The bond type, and how those factors influence its suitability for different materials.
Okay, let's say they throw a scenario at you. Imagine you're tasked with grinding a complex tool with intricate details. How would you approach it?
Precision and accuracy are key here.
It's like being a sculptor, shaping metal with incredible detail.
Right. Talk about your methodical approach, understanding the blueprints, the specifications.
You're not just grinding blindly.
You're following a plan.
Show them you're detail-oriented. You can turn a design into a real object.
With pinpoint accuracy. And the career guide talks about working with those blueprints, those technical drawings.
This is your chance to show them you can do it.
Right. Talk about selecting the right grinding wheel, setting up the machine with precision, making those tiny adjustments, constantly checking your work.
Those tiny details add up to a perfect final product.
And RoleCatcher can help you practice explaining those technical steps.
In a way that's clear, concise, confident.
Okay, here's another one. How do you stay informed about advancements in tool grinding technology and techniques?
Show them you're committed to continuous learning.
Always looking to improve.
Not content with the status quo.
You could talk about industry publications like Modern Machine Shop or manufacturing engineering,
Trade shows, webinars,
online forums, professional organizations like the SME.
and mention any courses or training you've done or are planning to do.
The career guide stresses the importance of staying up to date. This field's always evolving.
Show them you're dedicated. Okay, let's talk safety again. What are some key safety considerations when operating a tool grinding machine?
Safety first, always.
Show them you understand the importance of a safe work environment.
It's not just about protecting yourself.
It's about everyone around you, creating a culture of safety.
Right. Start by talking about PPE.
Those safety glasses, gloves, ear protection, your first line of defense.
Exactly. Don't just say, I wear PPE. Explain why they're important.
I wear impact-resistant safety glasses to protect my eyes from flying debris.
Heavy-duty gloves to shield my hands from sharp edges and hot materials.
Exactly. Show them you understand those safety protocols.
Lockout, ackout procedures.
Prevent accidental startup during maintenance.
Keeping the work area clean, organized.
A cluttered workspace is an accident waiting to happen.
The career guide emphasizes that. A clean and safe work environment.
Okay, let's get technical again. Can you describe the process of cylindrical grinding?
And its common applications.
Time to showcase your expertise.
Cylindrical grinding, it's all about creating those precise cylindrical shapes.
Shafts, axles, anything that needs a smooth, round surface.
The career guide highlights this as a key skill.
So be ready to explain the different types. External grinding, internal grinding, centerless grinding,
Describe the principles behind each method.
and their applications in different industries. Use real-world examples to bring it to life.
Okay, what about surface grinding?
They might ask about that too. Creating those flat, smooth surfaces.
Right, precision plates, machine tool beds, things like that.
Explain the basic principles. The workpiece is usually stationary,
Held on a magnetic chuck or clamped to a table.
and the grinding wheel moves back and forth.
Removing material, creating that smooth finish.
The career guide mentions this as a valuable skill, so be ready to talk about its applications.
Horizontal spindle grinders for large surfaces, vertical spindle grinders for smaller parts.
And the importance of choosing the right wheel, coolant, and parameters.
Okay, imagine they throw a curveball.
Yeah.
You're grinding a tool and the surface finish is rougher than expected. What do?
Troubleshooting time. Every tool grinder's favorite, right?
Don't panic. This is where you show your analytical skills.
Thinking on your feet. A rough surface can have multiple causes. Start by examining the wheel.
Is it worn, damaged, properly dressed?
What about the grinding parameters?
Speed, feed rate, coolant flow.
The career guide emphasizes problem-solving, analytical thinking.
This is your chance to shine. Walk them through your thought process. How would you check each potential cause? Make adjustments. Test the results.
Find the root of the problem and fix it.
All right, let's talk about centerless grinding. What are its key advantages?
This one's often used for high-volume production. Rods, tubes, pins.
Consistent diameter control, high production rates.
The career guide mentions this as a valuable skill.
Especially in industries that need high-volume precision manufacturing.
So explain the basic principles. No chuck or fixture here.
2 wheels, a regulating wheel and a grinding wheel.
They support and guide the workpiece.
The regulating wheel controls the rotation and feed rate. The grinding wheel removes the material.
It's all about consistency, making it ideal for large-scale production.
Okay, let's talk about safety again. What are some important safety precautions when handling and using grinding wheels?
Grinding wheels can be dangerous if not handled properly.
Always inspect the wheel for damage before you mount it.
Cracks, chips, wear and tear.
A damaged wheel can shatter. Those fragments can fly at high speeds.
And use the correct flanges, blotters, and tightening nuts.
To make sure it's secure, balanced.
An improperly mounted wheel can vibrate, even come loose.
And don't forget the wheel guard. It contains fragments if the wheel breaks.
PPE is essential, of course. Safety glasses, face shield, gloves.
Okay, back to grinding basics. What's the difference between internal grinding and external grinding?
Internal grinding, as the name suggests, focuses on the inside diameter of a hole.
External grinding is for the outside diameter of a shaft or a cylindrical feature.
Internal grinding needs special machines, special tooling. External grinding can be done on a wider variety of machines.
The career guide highlights both as key skills. Be prepared to talk about their applications.
Internal grinding for engine blocks, hydraulic cylinders, external grinding for shafts, axles.
All right, let's dive into tool and cutter grinding. What are its common applications?
This is all about keeping those cutting tools sharp and precise.
Drills, end mills, reamers, taps.
Essential for machining operations.
The career guide mentions this as a valuable skill, especially for tool grinders working in tool rooms or machine shops.
So be ready to explain the process, using specialized machines, holding the tool at specific angles.
The grinding wheel shapes those cutting edges.
It's delicate work. A steady hand, a keen eye.
And understanding tool geometry.
Talk about choosing the right wheel, dressing it to the right shape.
Using coolant to prevent overheating and damage.
Okay, back to grinding wheels again. Can you explain the difference between aluminum oxide and silicon carbide wheels and their applications?
Showcasing your knowledge of abrasive materials. Aluminum oxide and silicon carbide are two of the most common.
Aluminum oxide is tough, versatile, great for ferrous metals like steel.
It's the workhorse. Silicon carbide is harder, sharper. It excels with non-ferrous metals and non-metallic materials. Aluminum, brass, copper.
Glass, ceramics.
Think of it like choosing sandpaper.
You use the right grit for the job.
Be ready to discuss the different grit sizes for each abrasive.
And how grit size affects the aggressiveness of the grinding and the surface finish.
Coarser grits remove material quickly but leave a rougher finish. Finer grits are slower but create a smoother finish.
And don't forget about the bond type of the wheel.
Vitrified, resinoid, rubber.
That affects its performance too. Okay, let's talk about grinding wheel maintenance. Why is it important to dress a grinding wheel? How often should you do it?
Dressing keeps those wheels sharp and true.
As you use the wheel, the grains get dull, chipped, glazed over.
It's like sharpening a knife. A dull knife doesn't cut cleanly.
The career guide emphasizes tool maintenance, including dressing.
Dressing removes those dull grains, exposes the fresh, sharp edges.
Restores the wheel's cutting ability.
How often you dress it depends on a few factors.
What kind of grinding operation? What material are you grinding? The parameters, the surface finish?
Harder materials, more aggressive grinding usually means more frequent dressing.
Okay, let's imagine you have multiple tool grinding jobs with different deadlines, different complexities. How do you prioritize your workload?
Show them you can handle a busy environment, deliver quality work on time.
It's all about organization.
Start by explaining how you assess each job. Review the work orders, note the deadlines, specifications, instructions.
Prioritize based on urgency, complexity, available resources.
And the potential impact of delays, like a triage system.
What tools and techniques do you use to manage your workload?
A task list, a scheduling system.
Do you break down complex jobs into smaller tasks?
Show them you're organized, efficient, you can handle multiple demands.
Okay, let's talk about gear grinding. What are its advantages over other methods?
Gear grinding creates precise tooth profiles, those smooth surface finishes, for smooth, efficient operation.
Gears are in countless mechanical systems.
Gear grinding ensures their accuracy, their durability.
The career guide highlights this as a valuable skill.
Especially in industries that manufacture gears and gearboxes.
So be ready to explain the advantages over other methods. Milling, hobbing.
Gear grinding is more accurate, better surface finish, and you can grind gears with hardened surfaces.
Mention the different methods too. Form grinding, generating grinding, profile grinding.
Okay, let's dive into surface integrity. What are some common issues that can arise in grinding? How can they be prevented or mitigated?
Surface integrity, it's the condition of the surface after machining.
Things that can affect the performance, the durability, the reliability of the component.
Right. Surface burns, residual stresses, micro cracks, surface roughness,
Those are just a few.
and they can be caused by a lot of things. Excessive heat, wrong parameters, the wrong grinding wheel.
Surface burns, they're caused by too much heat. That can weaken the surface, make it more prone to failure. Residual stresses, they can warp or distort the component over time.
Micro cracks, those tiny cracks, they weaken the material. And surface roughness, that increases friction and wear.
So how do we prevent these issues?
Give us the secret formula.
It's a combination of things. Choosing the right parameters, minimizing heat generation,
Selecting the right wheel, the right coolant,
proper work holding techniques, preventing vibrations,
and taking advantage of new technologies.
high-speed grinding, creep feed grinding.
It's about having a whole toolbox of strategies.
By showing you know how to handle these issues, you demonstrate your understanding of maintaining surface integrity. And that's key for producing high-quality components.
All right, let's get into crankshaft grinding. Describe the process and what are some of the challenges involved?
Crankshafts, they're the heart of an engine.
Converting that reciprocating motion into rotational motion.
Crankshaft grinding, it's a specialized operation. Grinding those journals and crank pins to precise tolerances.
The career guide highlights this as a specialized skill, especially for those working in automotive industry or engine rebuilding shops.
It requires specialized machines, specialized tooling. It's a multi-step process. First, you set up the crankshaft.
Dress the wheel to the right profile.
Grind those journals and crank pins to the right dimensions.
Inspect for accuracy, surface integrity.
Precision and attention to detail are everything.
What are some of the challenges with crankshaft grinding?
Well, you need to maintain the correct journal alignment, the roundness.
If the journals aren't perfectly aligned, it can cause vibrations, wear in the engine.
Preventing taper and out of roundness is also crucial. Those journals and crank pins need to be perfectly cylindrical.
And achieving the right surface finish.
Crankshaft journals need a specific finish to retain oil, prevent wear.
Okay, let's talk about learning. How do you approach learning a new tool grinding technique or operating a new machine?
This is where you showcase your willingness to learn, your adaptability.
Show them you're excited to learn new skills, embrace new technologies.
Talk about seeking out training, consulting manuals, online resources.
Observing experienced operators, practicing on scrap material.
Emphasize your ability to follow instructions, ask questions, learn from your mistakes.
Show them you're not just willing, but capable.
Okay, let's talk grinding fluids. What are the different types and their purposes?
Grinding fluids, also known as coolants, they're essential for the process.
They dissipate heat, reduce friction, lubricate, flush away debris, improve the finish.
Like the lifeblood of the operation.
There are three main types: water-based, oil-based, and synthetic.
Each one's got its own properties, its own ideal applications.
Water-based are usually less expensive, good for cooling, but they can rust ferrous metals.
Oil-based have great lubrication, rust protection, but they can be flammable.
Synthetics offer a balance, but they can be more expensive.
Just like with wheels, choosing the right fluid depends on a lot of factors.
The operation, the material, the parameters, the finish you're going for.
All right, what about thread grinding? Describe the process and its advantages over other methods.
Thread grinding, it's all about creating precise threads. Bolts, screws, nuts.
Anything with a threaded connection.
The career guide highlights this as a valuable skill.
Especially in industries that make fasteners, precision components.
It offers several advantages over other methods like thread cutting or rolling.
Higher accuracy, better finish. And you can grind threads on hardened materials.
Be prepared to explain the different methods: single rib, multi-rib, centerless.
Each one has its own unique uses.
Okay, let's go back to the basics. Explain the difference between plunge grinding and traverse grinding.
Plunge grinding, the wheel feeds into the workpiece. The workpiece doesn't move.
Like drilling a hole.
It's precise, controlled.
Traverse grinding, the wheel moves back and forth across the workpiece. The workpiece might stay still or rotate slowly.
Like sanding.
So plunge grinding for precise cuts, traverse grinding for those smooth, continuous surfaces.
Which one you use depends on what you're doing, the shape of the workpiece, the finish you want.
Okay, let's talk camshaft grinding. Describe the process and what are the challenges.
Camshafts, they control the valves in an engine.
They dictate the timing, the performance.
Camshaft grinding, it's all about grinding those lobes to the precise profiles.
This is another specialized operation.
Requires a deep understanding of engines, And precision grinding.
It needs special machines, special tooling. First, you set up the camshaft.
Dress the wheel to the right lobe profile.
Grind those lobes to the right dimensions, the right finish.
And inspect for accuracy, surface integrity.
What are the challenges? Well, maintaining the correct lobe profiles and timing is crucial. If it's off, it can affect valve timing, engine performance, even emissions.
Preventing taper and out of roundness on those lobes is also key. They need to be perfectly symmetrical.
And the surface finish needs to be right for lubrication and wear resistance.
It's a lot more than just grinding.
You're shaping the heart of an engine. Okay, next question. What are some important factors to consider when choosing a grinding wheel?
Choosing the right wheel is crucial for getting those good results.
Like choosing the right paintbrush. The wrong one can ruin the whole thing.
The career guide says it's important to understand wheels and their uses.
Right. The most important factors are the material, the type of operation, the finish you want, and the machine you're using.
So starting with the material, how does that factor in?
Different materials have different properties. Hardened steel needs a harder abrasive. Aluminum might need a different type.
Like choosing the right sandpaper.
Exactly. Then you've got the type of operation, rough grinding, where you're removing a lot of material, or a finishing operation, where you need a smooth surface.
Different operations, different wheels.
And don't forget the machine itself, the power, the speed, the wheel size.
They all play a role.
The wrong wheel can be inefficient, give you a bad finish, even be dangerous.
Okay, let's talk about precision. Why is it so crucial in tool grinding? What are the consequences of inaccurate grinding?
Precision is everything in this field. Inaccurate grinding can have a lot of negative consequences.
Reduced tool performance, tool failure, safety hazards.
Right. If a cutting tool isn't ground right, it won't cut right.
Inaccurate cuts, more wear and tear, more heat, even breakage.
That can lead to rework, waste of material, production delays.
And safety issues.
An unbalanced tool can vibrate, damage the tool, the workpiece, the machine. It could even come loose.
So precision isn't just about quality, it's about safety.
Okay, last question for this section. Have you ever found a way to improve a tool grinding process? What was your approach?
Time to show off your initiative, your problem-solving skills.
Think of a time when you saw an opportunity for improvement. Maybe you found a way to reduce cycle times.
Improve accuracy, reduce waste, enhance safety.
Describe the problem, the steps you took, the results you achieved. Did you increase productivity? Reduce costs?
Make the process safer. Be specific. Use data.
Highlight those soft skills too. Your communication, your collaboration, your persistence.
Show them you're not just a worker, you're a problem solver, a difference maker.
It's all about making those improvements happen. And don't forget about communication.
Yeah, such a crucial skill.
The career guide really emphasizes that.
Makes sense. You're not working alone. You got to communicate with engineers, machinists, supervisors.
Right. Understand those project requirements. Make sure everyone's on the same page.
So how do you show off those communication skills in the interview?
Be a good listener. Engage with the interviewer. Ask questions. Show them you're really listening.
And when you answer, be clear, concise.
Avoid using too much jargon.
Find that balance. Showcase your expertise, but make sure they understand you.
And don't forget about nonverbal communication. Eye contact, good posture, confidence.
Those things matter. Okay, let's talk about a question that can be tough. What are your salary expectations?
Yeah, this one can feel tricky, but with some prep, you can handle it.
Do your research.
Salary surveys, online job boards.
RoleCatcher can help with this too.
Get a sense of the average salary range for tool grinders in your area.
With your level of experience, of course. And think about the cost of living.
Any special skills or certifications you have, those add value.
When you answer, be honest, be confident. Give them a range based on your research.
Based on my experience and the market rate, I'm looking for a salary in the range of.
And be ready to negotiate.
If their offer is too low, don't be afraid to counter.
You've got valuable skills.
You deserve to be compensated fairly.
All right, before we wrap up, let's talk about RoleCatcher one more time. How it can help you nail that interview.
It's like your secret weapon.
I love that AI analysis of job descriptions.
It picks out those keywords, the phrases that hiring managers are looking for, helps you tailor your answers.
Like having a cheat sheet.
You know exactly what they want to hear.
And the video practice feature is amazing.
Like a mock interview with an expert. You can record yourself, get feedback.
Practice makes perfect. Well, that's a wrap on our Tool Grinder interview deep dive.
We covered a lot of ground. Technical skills, those all-important soft skills.
We gave you the strategies, the insights to help you land that job.
Remember, preparation is key. Research the company, practice your answers, show them your passion.
And use RoleCatcher.
It can really make a difference.
We know you can do this.
Yeah.
Go out there and rock that interview.
Take your tool grinding career to the next level. Until next time, keep learning, keep growing, and keep diving deep.